students, now we will discuss equivalent resistance of combination of number of resistances. Now our problem is find the equivalent resistance in the figure below. This is the figure in which various resistance are connected as shown in the diagram. In first element, the resistance are capital R and capital R. In the next element, alpha R and alpha R. Similarly, in next element, multiplied by alpha, it becomes alpha square R and alpha square R, and so on. Multiply the resistance of previous element by alpha up to infinity. We have to find resistance between A and B. Let these are 2 points C and D after the first element of two resistance R and R. Now solution is, the given circuit is as shown in the diagram. First element, two resistance R and R. Next element, multiply previous resistance by alpha, it becomes alpha R and alpha R. Then again multiply by alpha, it becomes alpha square R and alpha square R, and so on up to infinity. These are the 2 points between which we have to find the equivalent resistance, and these are the 2 points C and D after the first element of two resistance R and R. Let equivalent resistance is capital X, that is resistance between A and B is capital X. Now it is very important point. It is observed that if each resistance in the circuit is multiplied by a constant, then equivalent resistance is also multiplied by same constant. Therefore, if we multiply each resistance by alpha in the given diagram, the new circuit is as shown in the diagram. First element containing resistance R and R, when multiplied by alpha, it becomes alpha R and alpha R. In the next element, resistances are alpha R and alpha R. If we multiply by alpha, it becomes alpha square R and alpha square R. Similarly, in third element, alpha cube R and alpha cube R, and so on up to infinity. Therefore, the equivalent resistance is also multiplied by same constant alpha and is alpha X. Let these are 2 points C and D, or A and B are same, and resistance between C and D become alpha X. When we multiply each resistance between A and B by alpha, the equivalent resistance become alpha X between point C and D. Therefore, the given circuit becomes, draw first element of two resistances R and R between A and B, and equivalent resistance between A and B is capital X. Now if we remove first element, the remaining circuit we left is same as we multiply the previous circuit by each resistance by alpha. That is, remaining circuit becomes same as we obtained from the given circuit by multiplying each resistance by alpha, that is between C and D, and therefore the equivalent resistance is also alpha X. So between C and D, the resistance of remaining part is alpha into X. Now in new circuit, this is the new circuit. First element remains same, containing two resistance R and R, and remaining part, the resistance of remaining part is alpha X, and between A and B the equivalent resistance is X. Now these two resistances in the new circuit are in parallel, that is resistances R and alpha X, they are parallel to each other, and let their resultant is small r, given by small r is equal to product of resistance upon sum of resistance, that is alpha x into r upon alpha x plus r. Put this equation number 1. Now circuit becomes like this. Now there are two resistances, capital R and small r, between A and B, and equivalent resistance is same X, which we have to find. Now small r and capital R are in series and their resultant is capital X. Therefore, according to question, small r plus capital R must be equal to capital X. Put the value of small r from equation 1, we get alpha x r upon alpha x plus r is equal to X. In the left hand side, take LCM, we get alpha into r into x plus r into alpha x plus r within the bracket upon LCM alpha x plus r is equal to X. Now cross multiply each other. So we get X into within the bracket alpha x plus r equal to alpha r x plus alpha r x plus r square. That is, after opening the bracket, we get this equation. In the left hand side, again open the bracket. So we get alpha x square plus r into x is equal to 2 alpha r into x plus r square, as alpha rx plus alpha rx is equal to 2 into alpha rx. Or taking the all the term to the left hand side, we get the quadratic equation alpha x square minus 2 alpha rx plus rx minus r square equal to 0. That is alpha x square minus, taking rx common, we get minus 2 alpha minus 1 within the bracket into rx minus r square equal to 0. Now solving this quadratic equation, we get, therefore capital X is equal to minus into minus 2 alpha minus 1 within the bracket into capital R plus minus square root minus 2 into alpha minus 1 within the bracket into capital R whole square minus 4 alpha into minus r square whole upon 2 alpha. Because using the formula of quadratic equation, x is equal to minus b plus minus under root b square minus 4ac upon 2a. Now in this case we get b is equal to minus into 2 alpha minus 1 within the bracket into capital R. So we get minus b plus minus under root b square minus 4 into a is equal to alpha and into c is equal to minus r square upon 2a, a is alpha. So we get x is equal to 2 alpha minus 1 into capital R, as minus into minus become plus. Now neglecting the minus sign because resistance can never be negative. So we get plus square root 2 alpha minus 1 whole square into r square, as square of minus term is plus. Plus minus and minus become plus. So we get plus 4 alpha r square whole upon 2 alpha. Now solving again, that is neglecting negative sign, as resistance cannot be negative. Solving a again, we get x is equal to 2 alpha minus 1 within the bracket into capital R plus square root of opening the whole square, we get 4 alpha square plus 1 minus 4 alpha within the bracket into r square plus 4 into r square, 4 into alpha into r square whole upon 2 alpha. Now within the square root, open the bracket, we get capital X is equal to 2 alpha minus 1 within the bracket into capital R plus square root of 4 alpha square plus 1 minus 4 alpha into capital R square plus 4 alpha R square whole upon 2 alpha, or capital X is equal to 2 alpha minus 1 within the bracket into R plus square root of 4 alpha square plus 1 minus 4 alpha plus 4 alpha within the bracket into r square, that is taking common r square whole upon 2 alpha. Now minus 4 alpha and plus 4 alpha cancel each other. So we get capital X is equal to 2 alpha minus 1 within the bracket into capital R plus square root of 4 alpha square plus 1 into capital R whole square upon 2 alpha. Now capital R square and square root cancel each other. So we get capital X is equal to 2 alpha minus 1 within the bracket into capital R plus capital R into square root of 4 alpha square plus 1 whole upon 2 alpha, or capital X is equal to 2 alpha minus 1 into capital R plus capital R into under root 4 alpha square plus 1 upon 2 alpha, or taking R common from the numerator, we get capital X is equal to 2 alpha minus 1 plus square root of 4 alpha square plus 1 whole upon 2 alpha into capital R. Therefore, the equivalent resistance X is equal to 2 alpha minus 1 plus square root of 4 alpha square plus 1 whole upon 2 alpha into capital R. So this is the answer of equivalent resistance of the combination of resistances in the given diagram. So thank you very much.